All right, you guys, these are the notes for systems. And I guess the first thing you should be wondering, or at least be able to answer, this is actually something I really almost feel like always asking on a test. And that is, what is a system? Okay. What is a system? When they say system, what does that mean? And it means two or more lines. Okay. So, what that means is that you are talking about graphing more than one line. So far, we've only been graphing one line. Well, now we're going to start graphing more than one line. So, you probably are thinking in this case, like, okay, maybe you have a line here, and maybe you have a line here, and you can see that the solution is the point that is on both lines. That is the solution. Okay. Usually, not usually, I shouldn't say usually, uh, you can have three different types of solutions. Okay. Or no, no, no. Let me not say it that way. You can have three different types of situations. Okay. You have one solution. This is where the graphs intersect. Okay. You could have no solution. That is when the graphs are parallel. Okay. This is a situation of no solution. And then the last one is when you graph a line and then you go to graph another line, the same line. You just couldn't identify it. Sorry, it's really hard to draw these, so I can't really do it very well. But they're the same line. That is all real numbers or infinitely many. All right. So, first of all, as long as you know this, as long as you know kind of what we're doing, we're basically looking at lines, multiple sets, multiple lines in one plane, and seeing how they intersect. Okay. So, for this problem, the very first thing you need to be able to do is the most simplest, which is this point a solution to the system? This is a system. Why is it a system? Because there's two lines. You can tell there's two lines because look, there's not a square. They're both to the power of one. So this is a line and that is a line. Okay, is it a solution? So the way you do this is you simply plug it in and see if it is a solution. I'm going to have to erase this, you guys. So let me do that. Okay, the way I do it, I like to do it is just write the two equations on the top here. So 2x plus 5y equals -6, and 3x minus 2y equals -9. And then what I like to do is just start plugging in the points. So remember, a solution has to fit both equations. So if it works in this one, then I plug it into that one. Okay, so let's see. 2 times 0 is 0. 40, 5 times 8 is 40, does not equal -6. And remember, this is a question. We are asking, is it a solution? So we're asking if it yields a true statement, then yes, it is on that line. So answer is no. If it's not on the first line, we don't care if it's on the second line. Move on to the second problem. Okay, so now we're going to plug in the second point, 7, -4. And you just proceed to do this for each point. Okay, so we're doing, let's see, so 2 times 7 plus 5 times -4, is that equal to -6? Well, let's try it. 14 plus -30, is that equal to -6? 14 plus -30, no, that is -16. So nope, it isn't it. So that answer to this one is a big fat no. All right, moving on. Let's get the next one. Okay, so grab the next one and you're just going to plug it in. By the time I erase, you guys should probably have it plugged in by now. If you don't, got to work a little faster. Okay, so here we go. 2 times 6 plus 5 times 2, is that equal to -6? 2 times 6 is 12, plus 10 is not -6. Wow, these things are weird. I thought for sure we'd get one that was like true. Okay, so far, nope. Oh, so far, is not true. All right, -5, so 2 times -5 plus 5, oops, sorry, that's not there. Mm, plus 5, I don't like that, sorry. That's ugly. I can't leave that like that. Can't leave ugly stuff there. Okay, 2 times -5 plus 5 times -3. Is that equal to -6? -10 plus -15. Nope. Guess what? None of these are solutions. What you would end up getting is something like -9 equals -9 and -6 equals -6. And then you would have been like, yeah, that's the solution. But we didn't get one of those. So that way you know what you're looking for. Okay, then the next thing you're going to do is graph. Okay, when you're doing graphically is my least favorite way to solve a system because it's inaccurate. Like unless they meet right at the intersection of a really sweet point, it's hard to read. You can't be sure. So, in my opinion, to graph lines, it's a little easier to change it to y equals mx plus b. So I'm going to take 6x minus 2y equals 6, and I'm going to say -2y. I think of it like this. I think like, ooh, I'm going to jump it over and change the sign. Plus 6. You can say subtract it from both sides. That's fine. Now you got to divide everything by -2. I often show this work to prevent myself from making stupid errors because that's the kind of stupid errors that I personally make. All right, so here's my first line, and I would go to graph it. Okay, here I go. 1, 2, 3, -3, up 3 over 1, up 3 over 1, and then I would draw the line. And this is almost nearly impossible on my tablet, so sorry. Here we go. Okay, and then you go to graph the next line, and you're like, okay, y is equal to 3x minus, oh, look, here it is. Oh, wait, but I go up 3 over, oh, no, look, it's the same point. Oh, look, it's the same line. Samey, same. Samey, same. Okay? If they're the same line, then the answer is infinitely many, all real numbers. Okay? It can be any number ever. Okay? Moving on. Just so you know, just a reminder, you could get parallel lines. You could also get one solution when you graph. Okay? All right. This is kind of nice. This is using a graphing calculator. Um, you're going to have to use the Alex one. And I'm going to assume that you're going to have to feed it into the calculator as y equals mx plus b. This is me. I fed it into the calculator on Desmos. And you can see that, look, here's the point right here. 0.667 and -3.33. And if you look, yikes, 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 what did I just do? I don't want to do that. I don't know why I did that. Okay. If you look at, okay, if you look at the problem, it says round to the nearest hundredth. Okay. So you would be, it would be 0.67, 0.67, and 0.67, and then y would be, what was, oh, hey, why didn't you graph it? Where did it go? Where did it go, you guys? Oh, wait, is it because my mouse is in my hand? Not sure. Ooh, look how weird. Desmos, Desmos, did you go crazy? Reload. Okay, I don't remember what it was. Y is equal to x plus 4. Okay, I lost my Desmos graph. I don't know what happened. Leave. Leave me. Okay, I can't remember what it was, but you would round off the next one. Okay, I'm not going to finish it. You just put it. That would be your 2 points. I mean, your 2 point, your 1 point, your 2 coordinates. Okay, and then they're going to give you something like this. Okay, this is advanced. It says using a graphing calculator, it's advanced because you probably need to solve for y first. Okay, if you solve for y, it's going to look like this. 4 minus 0.8x equals 0.5y. Well, you just got to get the y by itself. Some of you guys might not be happy with the y on the wrong side, so you could rewrite it in terms of y equals x mx plus b. Like, you could rewrite it so you could understand it. The slope is, well, we don't know what the slope is yet because I have to divide everything by 0.5. 0.5. And then you're going to get y is equal to, and then you'll use your calculator and get this decimal, and then use your calculator and get this decimal, which is going to be 8. It's not a decimal at all. But you'll get this decimal. And then once you do that, I'm just like, okay, I'm going to do this. It goes into 8 one time, 3. It goes into 30, 1.6. So it's going to be negative 1.6x. So this is what you're going to feed into the graphing calculator. That's why it's a little more advanced. This one, you need to just move the y over. I mean, not the y, the x term over. So you're going to get negative y is equal to negative 0.3x plus 1.1. And then we don't want negative. So we're going to multiply everything by a negative 1. Okay. Okay. So you're going to get y is equal to 0.3x minus 1.1. And that is the second equation that you're going to graph. And you are going to look for the intersecting point for that. So don't think you're done if you've gotten to that point. You're looking for the x and the y intersection. The x and the y point of intersection. Okay, so if I go to Desmos, hopefully it'll work. I'm not sure what happened. That was weird. I've been dealing with lots of weird stuff tonight. So yay. Okay, first one is negative 1.6x plus y equals negative 1.6x plus 8. There we go. We can zoom out a little if we want so we could see it. Wait, maybe pull it over a little. That's weird. Okay, there we go. And then let's go back. And then it's y is equal to 0.3x minus 1.1. Okay, and there you go. There's our intersection. And then you would need to round it to the nearest hundredth. So that would be 4.79.34. 4.79.34. So the answer would be 4.79.34. Okay, moving on. All right, this is the easiest system to solve, in my opinion, because they're already coming solved for y. You have two lines and they are both solved for y. So this is the case of like if star equals circle and star equals triangle, circle equals triangle. Would you not agree? If star equaled circle, star equaled triangle, circle equals triangle, right? What we did was we took these two and we basically, we could eliminate this because they're both equal to that. That's the situation here. Y is equal to this and y is also equal to that. So if you wrote the first equation, 9x minus 4, you'd be like, oh, but I know what y is. I can erase y. And whoa, honey, going crazy over there, little eraser. Okay, here we go. And then you can write 6x plus 8. So you set them equal to each other, but you set them equal to each other because they're both equal to y. So we subtract 6x from both sides. Okay, and you're going to get 3x minus 4. On that side, 8. You're going to add 4. You're going to get 12 equals 3x. So x equals positive 4. All right, and if x equals positive 4, how do you find y? You're like, woo, I found x. Yay! But you're not done, okay? You've got to take this x and you got to plug it back in to one of these equations. It doesn't matter which one. Everybody's like, oh my God, which one do I do? Doesn't matter. Plug it in. So I'm going to plug it into the second one because it has a plus sign and I like pluses. Let's be positive. Okay, y is equal to 24 plus 8. So therefore, y is equal to 32. So it's a really good practice. See how we plugged it into the second one to get 32? It's a really good practice to double check your answer by plugging it into the first equation. So look, 9 times 4 is 36. 36 minus 4 is 32. Oh, look, we got it. Y equals 32. Check, check. All right. Now we're getting into solving systems. Now, this is the heart of the lesson. The other stuff is really kind of easy in making sure that you understand what the heck a solution to a system is. This is the real stuff. Okay, and when I ask you to solve your system, well, you may not know this, but for your assessment for this unit, I am going to ask you to solve a system. I'm going to give you 2 lines, and you're going to have to solve it 3 ways: by graphing, substitution, and elimination. Okay, so here we go. The first one is substitution. Actually, the first one was graphing. What am I talking about? Miss Baca, you're tripping. I am. The first one was graphing. This one is substitution. So there is a method to substitution. And here it is. The first thing you do is you want to solve one equation for a variable. Okay. Then plug that variable into the other equation. And then finally, solve for the last variable. Okay, so to follow these steps, basically what it's going to do. Oh my God. Today, this board is driving me bonkers, people. You should see, I actually literally did the notes already, 30 minutes of notes on a different whiteboard program. And I was like, I felt so bad. I was like, no, I'm not going to do that. I'm not going to give them these crappy notes because I was struggling so much with technology. All right, so what I'm going to do is, okay, take a look at these 2 equations. 5x plus 3y equals 27. I could solve for one of these here. But look at this second equation. Y, okay, so y is already all by itself. So what I'm going to use for step 1, I'm going to use this and I'm going to solve for y. Y is equal to, so add 2x to both sides and I'll get 2x plus 10. Now I have what y equals. So I'm going to take that y and I'm going to plug it into the first equation. So it's going to be negative 5x plus 3y equals 27. Okay, negative 5x plus 3. And instead of y, we're going to put in 2x plus 10. That's the substitution. That's why we call it substitution. So we distribute 6x plus 30 equals 27. Okay, and then I'm going to, I don't want to erase it, but let's see. Can you guys see that we're going to get x? This is going to be x plus 30 equals 27. And then we're going to get x is equal to negative 3. Okay. Ugh, I'm sorry. I'm going to have to erase this. Hope you guys should actually have it written down. I might not be able to write it down, but you guys can write it down. Okay. I'm going to do this with my other pen. It's so much easier. Okay. Get rid of that. Okay. All right. So let's go ahead and finish this problem. We're going to go x plus 30 equals 27. X is equal to negative 3. Okay, now we found x. So the simplest way would be to plug it back into that. The problem with that, well, first of all, there's not a problem in the beginning. Okay, if you did everything right, there's not a problem. So we plugged it in for x, so we're going to get negative 6 plus 10, and y is equal to 4. The only problem that sometimes happens if people solve this incorrectly, and they plug this back in correctly, they're going to get the wrong answer. So here's the thing. Here's what you really do need to do. You need to take that answer and plug it into the equation you didn't use. So you need to plug it back in to like -5 times 3 and check to see if it actually works. Did you do it right? This is positive 15, whoa, not 75, plus 12. Is that equal to 27? And the answer is check. It is. So 27 equals 27. So yes, you know you did it right. I used to actually love systems. I like any kind of math test or math problem where I can determine that I actually got it right without having to ask somebody or check a reference. Okay, I actually included a second one. If you understand how to do this, you can zoom ahead in the video to the next problem. If you're having trouble, what I recommend you do is actually stop and try to stop the video now and try to do this problem by yourself and then watch my solution. I'm going to do this one quick. Okay, here we go. Okay, this one, X is already solved for. So I'm going to take this and I'm going to plug it into the first equation. Okay, so we're going to go -5 times 3y minus 15 equals 20. Oh, no. Ugh, sorry. You know what's a really good practice, and I think I'm going to employ that right now, is write the equation before you substitute in. So, ready? -5 x plus 3y, just write it as it came, equals 27. And then substitute in. So you're not like trying to memorize crap or you don't lose your place and grab half of the equation from one problem and half from another. Okay, now we're going to distribute -15y plus 75 plus 3y equals 27. 75 came from 5 times 15, guys. Okay, so add our y's together. We're going to get -12y plus 75 equals 27. Subtract 75 from both sides, and you are going to get 75 minus 27, 8, 48, -48 because the 75 is negative. -12y equals -48, so y is equal to 4. Yay! Y equals 4. Okay, good. Now we need to find x. So to find x, we got to go back in and we got to plug it back into one of the equations. The easiest one to plug it back into is the one that's already solved for x, the one that they gave us. That would make the most sense, correct? So let's go back and plug it in. I'm sorry, I'm not erasing it completely because I have no patience. Here we go. Okay, so we're going to go 3y minus 15 equals x. 3 and y is 4, you guys. Minus 15 equals x. So that's 12 minus 15 equals x. So -3 equals x. And now we got it. The point is -3, 4. Now, I used this one, to solve for y. So I should check it with that one. So let's do it. -5 times -3 is 15, positive 15 plus 12 equals 27. Okay, and it worked. Look. Next. Okay, this is solving a system of linear equations using elimination with addition. All right, this one. This is my absolute favorite kind of problem or method to solve. So this is the third way that you're going to have to do it. It's called elimination. The reason why it's called elimination is because you are going to eliminate one of the variables. Okay, so I don't really know how to write that in language that isn't like a paragraph, but the idea is to get the situation where you can cancel one of the variables. So look, you guys, if I add these two equations together, check it out. 2y and -2y are going to cancel each other. They're out. They're opposites. So -3 plus 6 is 3x equals -6. Add those two together. x equals -2. And we found x. All we need to do is plug it back in. It doesn't matter which equation. Pick one that you like. I'm going to pick 6 times -2. Actually, again, make a good habit of writing the equation first. I'm being kind of lazy, and that's not good. It's only because I've already done this exercise, like I've already done these notes almost like twice or 3 times. It's been pretty brutal for me. -12 minus 2y equals -10. And then add 12 to both sides. And you're going to get -2y equals 2. Okay? And y is equal to -1. So now we've got our x and our y. That is the point where these two lines meet. Double check it by plugging it in to the equation you didn't use. I used the second one. So I'm going to go 3 times -2. This is just a check. Nobody's going to ask you to do this on Alex. This is just, it's good practice. 3 times -2 is -6 plus -2 is not equal to 4, y'all. Oh, it's +6. It's -3. No wonder I was like, what? I did it wrong? That's supposed to be a +6. So the answer is yes, indeed, we did it right. Doing good. All right, next one. Same thing. Okay, so again, if you understood and you don't need to do this, move on. And the next one is if you want to, maybe, what happened? I did everything. I got too big here. Okay, maybe stop and do it yourself. Okay, I don't know what I did. There we go. What the heck I was doing? I need to get a bigger frame. There we go. Oh, I did not know I could do this. Look at that, y'all. Okay, cool.